Okay, so here are the notes for modeling with systems of equations. Systems of equations are often used to compare two scenarios, taking multiple variables into account. We really use systems all the time without realizing it. If you wanted to figure out whether it would be better to rent or buy snowboarding equipment, that would be comparing a system of equations. And in the end, when you decided the best case scenario, you would have solved that system of equations. So we're just going to start out very simple though, because it doesn't matter what the system is. It's all about how you set up your work and work your way through it. Now, you could use substitution or elimination, but in these notes, you're going to see me use elimination. Okay, so this is what all of the notes look like. This is just the entire sheet. I think it should fit on one piece of paper, but I'm going to zoom in on the next, the top half of the notes. So here's my model problem, a very simple problem. So it says there are 13 animals in a barn. Some are chickens and some are goats. There are 40 legs in all. How many of each animal are there? So the first thing we want to notice is what the topic is. There's chickens and there's goats. Okay? So we're going to take those topics and we're going to define our let statements. And you noticed in lesson 5, Kurt actually started to talk about let statements. And we talked about them yesterday in our Google Meet. So C can't just equal chickens. It has to represent more than that. And that's where this last sentence of the question comes in. It says, how many of each animal are there? That tells me that C actually stands for number of chickens. And I'll abbreviate chickens. And then he talks about goats, and we have G can represent number of goats. Okay, the next part of this table says write two equations using your defined variables, so that's C and G, and determine what number to distribute in order to make additive inverses. So we're going to take C and G, but we're going to go back to the problem and read what tells me some more information about chickens and goats. So if there's 13 animals in the barn, 13 animals in the barn total, that tells me that since there's only chickens and goats in the barn, all the chickens and all the goats add up to 13. That's one of our equations. So C plus G equals 13. That's going to be the simpler of the two equations that we use. Then there's more information. The other sentence, the other equation, is going to come from this information where it says there are 40 legs in all. Now, we have to bring a little more to the table though. So 40 legs in all tells me that there are 40 as a total number. So that lines up with the 13 because those numbers are both total numbers. And I know that I'm going to need a C value here and a G value here, but it can't just be C plus G again because that wouldn't make any sense. C plus G can't equal 13 and 40, so there must be something else about C and something else about G that we can do. So, what could we do? Well, come back up here. What do we know about chickens? And what do we know about legs? And what do we know about chickens and their legs? We know that there are 2 legs per chicken. That's like saying 2C. And what do we know about goats and their legs? Well, we know there are 4 legs per goat. So that's where this other equation is going to get its C value or its C term and its G term. So now we have 2C plus 4G. Awesome. The very next step, which is still in this part of the table, is to determine what number to distribute. Determine what number to distribute. And if you look, I'm going to distribute the top equation I'm going to distribute into the top equation by -2. Because that -2 and this +2 will eliminate when I'm done. So here we go. Over to the right, it says rewrite your distributed equations, total and solve. Okay, well, my blue equation is going to be changed a little. My green equation is going to stay the same. So my blue equation will turn into -2c minus 2g equals -26. And my green equation is going to stay the same. 2c plus 4g equals 40. I total them up, I eliminate c, and I end up with 2g equals 14. Let's just double check that. So 40 minus 26. Okay. So now we think ahead. We know that g is going to equal 7, but we just need to prove it. So divide by 2, and we get that there are 7 g's, meaning I can bring that over here to my solution. The number of goats equals 7 in the barn. All right, this last step, let's jump to right here. I'll start using gold here. So substitute what you know. Now, when it comes to substituting, always pick one of the original equations, and remember what I said in the beginning of all this. Pick the easier of the two. I'm going to pick the original c plus g equals 13. This is the simpler of all the equations. And I'm going to substitute what I know about g. So I know that g is really 7. I subtract and I get that c is equal to 6. So that comes over to our solution. And since this is not an ordered pair, this is not an x and a y relationship, we don't write it as an ordered pair. We just state the solution. Okay? Maybe even box it out when you're done. So this tells me there are 7 goats and 6 chickens in the barn. Okay, pause the video if you need to. I'm going to move on to the next slide. All right. So this next problem, example number 1, I have a jug at home with 20 coins. Some coins are nickels.